Good day. So we're just continuing from functions, basic functions from last day. We're using the same two functions, f at x and g at x. A composite function though, composed of more than one function, if you notice. Before we just had one letter, and again I just have it on the back of the page here. We just had one letter to deal with. Now we have two functions, or two letters, as you'll notice. So we have two ways to do this. I'm going to show you the easier way first, and then we'll look at the advanced way after. So fg at 3 means I want to stick 3 into the closest number first, the closest letter, closest function first. So I have to do it in a specific order. So what I'm really going to work out is, since the 3 belong to or closest to the g function right now, I'm actually going to stick the 3 in the g function first. So what I'm going to do is, I put in brackets on it just to let me know I'm doing that first. So I'm going to work out g at 3 first. And if we already know the g function is 2x minus 5, wherever I see x in the g function, I'm going to replace it with 3. So instead of having 2x minus 5, I'm going to have 2 times 3 minus 5. 6 take away 5. So g at 3 really work out to 1. So in other words, this whole bracket that I put here really work out to 1. That's the answer for g at 3. So what I'm going to end up having as, I have the f waiting, I had already drawn my brackets, and the answer for inside here turned out to be 1. So what I have now, I work this out, it turned out to be 1, and then I take that answer now and I'm sticking it into the f function. The f function is 3x plus 4, but in place of x, I'm going to put 1. So now we have 3 times 1 plus 4. 3 times 1 is 3 plus 4, so my overall answer going to be 7. So you realize what we did here? We're doing the same thing we did in the first part, we're just doing it twice. If we had 3 functions, in other words 3 letters, we'd do it 3 times. But at this level you don't go more than 2 times. So again, just to recap, taking the value, sticking it into the function, working that out. When I get my answer, sticking to the next awaiting function. Then we look at the next one. So do you think that fg at 3 and the function gf at 3 going to be the same value, which was 7? Well, let's see. So again, this needs to work out first. The 3 closest to the f, so I'm going to find a spot and work him out first. So f at 3, again, just to remind myself, the f function, 3x plus 4, I replace an x with 3, so it's going to be 3 times 3 plus 4, multiply first, 3 3s are 9 plus 4, so this work out to 13. So that means here work out to 13. So what I really have now is g at, this whole thing work out to 13, in other words the answer that I get here. So now I'm going to stick this into the g function. So wherever I see x in the g function, which is 2x minus 5, I replace an x with 13. Now I have different ways there. You keep seeing me using the multiply and multiply, but you could use brackets as well. So I just want to show you the both ways, whichever you're more comfortable with, you use that. So brackets again mean multiply, so if you prefer put that multiplication sign, or you prefer put the brackets, is up to you. So 2 times 13 minus 5, 13 by 2 is 26, take away 5. So the answer is not the same. So don't assume that this is the same thing as this. You can see it's different. One of the answers was 7, the next answer was 21. Let me look at the next one, because again, you're going to bounce up some negative values. So we're going to look at fg at 0, which means I'm going to put my brackets on it and stick 0 into the g function first, only because the number closest to that function, that letter that represents the function name g this time, we're doing that part first. So I'm going to work out g at 0. So g at 0 means I'm looking at the g function, and in place of x, again just to remind you of the g function there, 2x minus 5, in place of x I'm going to put 0. So anything times 0 is 0, take away 5, minus 5. So like I said, you would bounce up negative values a lot. So inside here really going to be minus 5, because that's what g at 0 work out to. So now I'm going to work out f at minus 5. So I'm looking again at the f function, 3x plus 4, and in place of x I'm going to put minus 5. So 3 times minus 5, or 3 brackets minus 5, whatever you want to do, plus 4. This part have to work out first. Again, recall when you're multiplying values, the sign don't matter yet. 5 3s will always be 15. It don't matter what signs the numbers have on it. 5 times 3 will always be 5 times 3, which is 15. But now I have a positive value, because the 3 don't have a sign, so it means it's positive, and a negative value, and a positive and a negative going to give me a negative 15 plus 4 I owe you $15, I pay you back $4, so I didn't pay you out yet, I still owe you $11. And that's my overall answer. Those are the easier versions of it. What if we had something like this now? FG at X. So you realize if we don't have a number, which is the case here, I didn't have numbers, this is F at X, G at X. When I put in a letter, I'm going to get combinations of letters and numbers, but the letters are not going to anyway, the variable's still there. Same thing here. FG at X means I'm going to get something just like this, because this is really a function. It doesn't have a number value. When I stick in a X, I'm going to have X in my answer. When I stick in numbers, you realize I only have numbers. So once I have an X here, my answer is still going to have X in it, which making it a little more difficult because it'll be closer to algebra where you're seeing all these letters. So let me still do the same procedure we was doing before. Put my brackets on this, and now I'm going to stick X into G. The thing is, it might look a little difficult, but what is G at X? Well, the thing is, I don't have to work out G at X because they already give me G at X. This is G at X. G at X is really 2x minus 5. That's the easy part. And before, if you notice what we used to do before, whatever answer I get here, I'm going to put in place of that piece, meaning it will be in the brackets, and I have my next letter waiting outside. And the same thing I do for this one. Whatever answer I get here, I put it in brackets and then stick it in here. Whatever answer I get here, I put in brackets and stick it in here. So my answer this time is this, meaning this have to go in the brackets. And this is where the algebra part going to come in. So it's going to be F, I open my bracket, and my answer for here, which was 2x minus 5, that have to go in the brackets. Again, this is the advanced part, right? And it advanced because of the algebra that it has involved. So let me see what's going to take place. When I have a number, whatever the number value was, I'm going to replace X with. Here, I do have a number this time. I have all of this to put in place. X, right? This expression. So again, F at X, I'm going to do it a little slower this time. F at X is 3x plus 4. And normally whatever X is, I'm going to replace this X with that piece. So it's going to be 3, but in place of the X, they want me to put this whole thing this time. So I'm not going to put my multiplication time this time. I'm going to put my brackets. So that's what I replace in X with. Everything inside here, I replace X with. That's what you replace X with. And I still have my plus 4 waiting outside. So this is just pure algebra now. I have a number in front of the bracket, so that means I have to expand this bracket, which we did before. So when you expand in a bracket, it means multiply. And I'm going to multiply each piece in here by 3. So 3 by 2x, I'm going to get 6x. 3 by minus 5. 3 by 5 is 15. A positive and a negative, we did it up there. Going to be minus 15. And I have my plus 4 outside here. So this is really going to be 6x, and now I could group up numbers and letters. It have no letters to group up with 6x. He's the only x term, but these are numbers. So minus 15 plus 4 minus 11. So the overall answer for FG at X is going to be 6x minus 11. Why would we do something like this though? So I want to show you back 2 examples. Let me look back at this first one, FG at 3. So you realize once I have a x involved, that's really a function. So I can really take this and write this up here with the rest of functions. So now I have a third function, 6x minus 11, because I created a new function. All of these are functions. One says f at some value called x, we call it a function. So this is a brand new function I created. So if I wanted to do back fg at 3, I don't need to do the two-step process. I already have a brand new function that already work out that process for me. So all I really have to do here is replace x with 3, because I already have a fg at x function. Alright, fg comes like the name of the function now. So similarly, if I replace in that x with 3, that means this x going to replace with 3. So I'm going to get 6 times 3 minus 11. 6 3s are 18 minus 11, and I get 7, which was the same thing we get here, but we got it shorter because we already had a function that work out these 2 steps already and combine them into 1. Now you wouldn't do this all the time. Sometimes they will ask you for something like this, but only if they ask you for it, then you'll do it. But sometimes they won't, right? Most of the time they won't. I just want to show you the advanced part. Similarly, we did fg at 0 here. Let me take a look at fg at 0. So if we want to do fg at 0, again, we already have fg at x. So I'm going to replace x with 0. So that means this x is going to replace with 0. we're now going to get 6 times 0 minus 11. 0 times anything is 0. Minus 11, 0 minus 11, minus 11, and guess what? That was the same answer we get up here when I tried to work out fg at 0. It just took 2 steps instead of 1, but I must have that function first. Alright? So for practice, if you like, you could pause the video and work out g f at x for yourself, and then you could try the question after and pause the video, but it'll be good if you try it for yourself. So g f at x, pause the video, try it, and then unpause, and you'll see the working for it. So that means I need to work out f at x first. So again, f at x, they already give me that, and if you remember, again I just showing you 3x plus 4. So that means inside here I'm going to replace with 3x plus 4. So now I have g, and inside the bracket I have 3x plus 4. And just to recall, the function is g at x is equal to 2x minus 5. So now I'm replacing x with all of this. So that means this x is going to replace with 3x plus 4, because that's what I'm replacing x with, minus 5. And just like before, I'm going to expand. Again, I just separate any work. That's why that line there. So 2 by 3x, 6x. 2 by 4, 8. I multiply each piece in here by 2. I have the minus 5 waiting outside. And again, just like before, letter terms of variables only could group up with other variables. So once it have a letter term attached, in this case x, he could only group up with other x's. So it have no other x terms, so he remaining as that. So all I could work out is plus 8 minus 5. 8 take away 5. Positive 3, meaning I get the new function. I get our next new function. G f at x is 6x plus 3. And just like before, I would already work out g f at 3. We know the answer is going to be 21. Let me see if we're getting it with our g f at x function. So in this function, I'm going to replace x with 3. So I'm going to get 6 times 3, because I'm replacing x with 3, plus 3. 6 3s are 18 plus 3, and I get in the same 21 that I had gotten when I did this one here, if you notice. So that's what composite functions will look like. This is the advanced part. Most of them going to come like this one though, or this one where you have some negative values. But we have one more type of function to look at, which is the inverse function. So we're going to look at that next.